Yeah, so question 59 from the homework, right? They tell us about percentage of carbon, hydrogen, oxygen. They want us to find the molar mass. They want us to find the molecular formula given the molar mass. So we're going to start with those percentages, right? 40.5 grams of carbon, 4.5 grams of hydrogen, and 55 grams of oxygen. We can't do anything with grams other than to find moles, right? We can't compare grams of carbon, hydrogen, or oxygen because they have a different atomic weight, right? But we can compare moles. So I got to find moles of each of those. I know for every 1 mole of carbon, right, it's 12 grams. 1 mole of hydrogen is 1 gram. And then 1 mole of oxygen is 16 grams. So we divide through, we find moles of each of those. So 40.5 divided by 12, right? We get 3.375. We get 4.5. And I think this one came out to be like 3.4375. All right, 55 divided by 16. That's definitely when you can tell we did this in class. I remember the exact number here. Moles, carbon, moles, hydrogen, moles, oxygen, right? The next step is the same, right? We're going to find the mole ratio by dividing by the smallest number, right? And so we're going to divide all of these by 3.375 to get our mole ratio. And I think this is the one that came out to be 1 mole carbon, 1.33 moles of hydrogen, and approximately 1 mole of oxygen. So that gave us the first empirical formula of CH1.3301. And here's where we can't have a decimal of an element. So how do I turn 0.33 into a whole number, right? We're going to multiply the whole thing by 3 to get an empirical formula of C3H4O3. We're not done there because this is our empirical formula, right? And they wanted to know what the molecular formula was. And we know that the molar mass is 176 grams per mole. So we got to figure out how to take our empirical formula into a molecular formula using that molar mass is 176. So to do that, we basically have to see how much does this weigh, right? And so that's where we would break this down to see, okay, I've got 3 carbons at 12 each. I've got 4 hydrogens at 1 each, and I've got 3 oxygen at 16 each, right? So 36 plus 4 plus 48, actually. Yeah, 48. Right, and we get, okay, that empirical formula weighs 88 grams per mole. I know the whole thing has to weigh 176 grams per mole. So I want to say, okay, if the whole thing is 176, I need to know how many times does this go in there. So basically, how many times do I have to multiply my empirical formula to make it my molecular formula? So 176 divided by 88, it goes in there twice. So we're going to take our empirical formula C3H4O3 and multiply it by 2 to get C6H8O6 as our molecular formula, which if we added up all the carbon, hydrogen, oxygen, it should equal 176 grams per mole.